In this video we are going to learn about drawing Lewis structures, and when you're drawing Lewis structures it's very important that you follow the procedure that is given in the book until you pretty much have it memorized, because if you don't and you just sort of start winging it, you're probably going to make some mistakes. So let's look at PCl3. The first thing that you do according to the procedure is you count up the number of valence electrons in the molecule. So there's one phosphorus, and phosphorus has 5 valence electrons, and then there are 3 chlorines, and each chlorine has 7, so that's 21 for a total of 26 valence electrons. And then we're going to divide those into pairs. It just makes it, you don't have to, but it makes the counting a little bit easier. So that means that we must, in our Lewis structure, when it's done, we must have 13 pairs of electrons. So once we have that, you will arrange the molecule in a preliminary tentative arrangement, and there are a bunch of rules in the book that tell you how to do this. The one that applies to this one is that if you only have one of a particular element, like here you only have one phosphorus, that's probably going to be the central atom, okay? And then you arrange the other atoms around it, like so. Then you connect the terminal atoms, which are the outer atoms, in this case the chlorines. You connect those terminal atoms to the central atom with single bonds. Each single bond, remember, represents a pair of electrons. So right now, with those 3 single bonds, we have put in 3 of our 13 electron pairs that we needed to. The next step in the procedure is to fill in the octets of the terminal atoms. Again, that's the chlorine. So you fill them in so that they all have a full octet and they are nice and stable and happy. Now let's see how many electrons we have put into our picture. So we have those 3 bonds. We have 3 lone pairs on each chlorine, which gives us a total of 12. We need to have one more, and we can't put any more on the terminal atoms. Those are all happy. So the only place that they can go is on the central atom. Now, once you've put all the electrons in, you check and you see, are all the electrons stable with an octet? And in this case, yes, they are. All the chlorines have a central, all the chlorines have an octet, and the phosphorus has an octet as well. All right, so that one's done. Next, the carbonate ion, CO3 2-. So the carbon has 4 valence electrons. Each oxygen has 6, and there's 3 of them, so that makes 18. And then this also has a -2 charge, so that means that there are 2 extra electrons on this particular one, which is a total of 24, which is going to give us 12 pairs. So once again, we're going to arrange this. I'll do it over here with the central atom and 3 terminal atoms. The next step connects them to the center with single bonds. That dot should not that should not be a dot, that's a carbon. So you connect them with single bonds, then you make the terminal atoms happy. And then you go back and you count to see if there are any others that you need to put in. Right now we have put in how many total pairs of electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have put in all of the electrons. We have no more electrons to put in. We have no extra ones that will go on the carbon. Now we go back and check to see if everybody's stable with an octet. And the oxygens are, but the carbon is not, which means that the final thing we have to do is make the carbon stable by creating a double bond. And the way you do that is you have to take one of these lone pairs and change it into a shared pair, like this. So instead of being a lone pair on that oxygen, this is now a shared pair with the carbon. So the carbon is now has an octet. That oxygen still has an octet, and everybody is now stable with an octet. The final thing to do for this one is, because it is an ion, you need to put brackets around it, like this, and then you write the charge in the top right hand corner of the brackets. Okay? Now, the last one. We have 3 carbons. Now this one's written a little bit differently, right? All the carbons are split up, and there's a reason for that, but we still count up the valence electrons the same way. So 3 carbons, each of them has 4, so that's 12. We have a total of 6 hydrogens, and each of them has 1, so that's 6, and then the oxygen also comes with 6. So once again, that's a total of 24, or 12 pairs. 12 pairs. Okay. Now in this case, there isn't one single central atom like there was in the other 2. There are a bunch of carbons, and one of the rules in the book is that carbon always is always in the center. It's never a terminal atom, and it likes to bond to other carbons. So carbons tends to form chains. So we're going to start out here by writing down 3 carbons all stuck together in a row, making a chain with single bonds. Then we're going to put our terminal atoms in, and here's where you look at how the equation or how the formula is written. So notice that the first carbon here is written with 3 hydrogens following it. The second carbon is written with 1 oxygen following it, and the third carbon is written with 3 hydrogens following it. So what that means is the first carbon has to have 3 hydrogens bound to it. So we're going to go ahead and put those in. It also means that the final carbon, the last carbon, has 3 hydrogens bound to it. So we'll put that in. And hydrogen always makes single bonds, so that makes that part easy. There's not a lot of guesswork going on there. And then the middle carbon has an oxygen bound to it. So let's go back and look now that we've done that on at how many electrons we've put into the picture. Let's just count up the bonds here. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 pairs of electrons, and we need to have 12 total. Okay, so we can put, so that means 3 more. This oxygen is not happy. I can put 3 lone pairs on that oxygen, and we have the right number of electrons, but the middle carbon still is not happy. So we will take one of those lone pairs from oxygen, and we will erase it and turn it into a shared pair with that carbon. And now everybody's happy, has an octet, and the structure is finished. That's Lewis Structures. Thanks for watching.